Hi everyone, good evening to all. Do let me know, am I audible or not? I'm waiting for the response and tell me how's everything going on. Mark your attendance, missing the names. Do let me know, then we'll start. Very good evening, Siddharth. Do let me know, am I audible to all? Good evening, Prince. Cool, yeah, cool. So now we already know that what we are going on. We are going on a really marathon, right? And in this marathon, we have already completed two steps. One is math, second is arrange. And now we are doing one two-pointer algorithm over arrange, right? We are understanding like how arrange can be modified in different algorithms. Okay, cool, yeah, cool. So now we'll continue. The problem statement of the day is remove duplicate from the sorted array. So I'm sending you the connection request in LinkedIn. Okay, Siddharth. Uh, okay, the problem statement is remove duplicate from sorted array. And this problem already has been asked in Adobe, Amazon, Apple, Bloomberg, Facebook, Google, Microsoft, Oracle, Uber, and other companies as well. It's a simple problem, but still this has been asked in multiple companies. So if you're preparing for any kind of coding interview, this may help you a lot. That's why I've chosen this problem because this has been asked repeatedly in multiple companies. So which means that if in past it has been repeated, so in future also it can be, right? And anyhow, not Adda, I'll search for LeetCode. We'll go here. Okay. And the problem statement was remove duplicates from sorted array, right? So we'll go to the problem section and here we'll search for the problem statement. Cool. And again, you notice one thing. You notice something. Something I want to show you. Here, topics and algorithms in Java, C++, and Python. Now, today onwards, I'll cover all the codes in three languages. First, we'll understand in Java, then we'll do that same translation in C++ and then Python. So this is for the people who were keep asking for Python, C++. So this may can help them as well. Okay, cool. Yeah. And again, important thing I want from everybody is that if you're new to this channel, you can subscribe this for have future updates. Second thing, you can share this live to your other friends. May this live can help them as well. Okay, and drop the comments, whatever you want. Whatever you want means not everything. Whatever you want in the logics. Okay, cool. Yeah. In terms of resources or something. Cool. Yeah. So now we'll go back to our LeetCode problem statement, and here I'll search for remove duplicates in sorted array, right? So I'll search for the problem statement, remove, I guess already caps lock is on, remove duplicates in sorted array. Okay, we have already covered this, but when? Really? I don't know. I don't think so. And we have covered this so far. I don't know when. Cooler. But now we'll understand this problem statement. But maybe in other batches I have covered. I've used this particular platform. But in this live we haven't covered this so far. Cooler. So given an integer array nums sorted in non-decreasing order means these already are sorted. Again, remove the duplicates in place. In place you know the meaning, right? In place you know the meaning. You cannot utilize other data structures such that each unique element appears only once, which means that you have array where all the values are sorted. Okay, like 1, 2, 3, 3, 3, 3, 3, 3. Sounds good. 4, 5, right? So that's how all the elements of the array are sorted in non-decreasing order. And again, what our job is to do, we have to remove duplicates in place, which means that we cannot utilize other data structure. Right? The relative order of the elements should be kept the same. Relative order means the order of the existing elements should remain the same. Now, then return the number of unique elements in the nums. After sorting this, we have to return like how many unique elements were there in the array. Okay, so now change the array nums such that the first k element of nums contain the unique element in the order they were present in the nums initially, which means their relative order should be preserved. Right, the remaining elements of the nums are not important as well of the size. I guess somewhere we have seen something similar problem in previous. Right, previously we have seen something similar. Cool, yeah. Cool. So now let's understand this particular test case. We have nums where we have value 1 comma 1 comma 2. We wanted to sort it in the terms like we wanted to remove the duplicates. Doing what? We wanted to remove duplicates by preserving the relative order, which means that we have here 1 comma 1. I want to delete this one. Okay, I want to keep this previous one. Cool. So now we have 1 comma 2, and you don't have to worry about the other values. They will remain whatever they were in the array itself. Okay, and now after that you have to return the number of unique element. So the one ideology people can have in their brain is that what if we convert this whole array into an hash set? So we will have the number of unique element. But trust me, that will not solve your problem. Why? Why? Because you need to do in place. And they have implemented something which will automatically check this nums, that this has been, updated in place or not. So that's why this problem is super critical, because people make a lot of mistakes in this. Why? Because they do not know what they have to do. So you cannot utilize the hash set. Why? Because you need to do this in place. So what can be the logic? So understand this, always click on the topics part and go like array two pointer, which means this problem statement it can easily solved with the help of two pointers, right? And anyhow we know two pointer means we will have two pointer and we will keep using them to swap the value, to delete the value or something, right? That's what we do. So okay, we'll understand by taking one example. Let's say this 0 comma 0 comma 1 1 1 1 2 2 whatever blah blah blah, a lot of values. We'll go to the slide part and we'll understand here directly. Okay, so now I'll take pen. First I'll choose the color. Now we have pen, and what I'll do, I'll explain you with the help of test cases, then we'll understand the code itself. Okay, in three programming languages, in Java, in Python, in CPP. Cool, yeah. So now not highlighter, actually I wanted a pen. Cool, yeah. So let's say we have a nums, okay, where we have value 0 comma 0 comma 1 comma 1 comma 1 comma 3 comma 4 comma 4. I'm assuming this is what we have. I'm assuming. Okay, cool, yeah. So now the thing is that we want to remove the duplicate values. It's already sorted, right? So we can have a one pointer here, right? Let's say this I call I. We can have another pointer here. Let's say we call J. Okay, so what we'll do, we'll check the value of them. Let's say this is nums, so we'll check the value of nums I. If this is equals to what? Nums J, then what you have to do? Just stay, this I pointer should stay on the same place and J pointer should increase, right? Which means that in future what we'll do, we'll replace this upcoming value, right? So this I will hold the unique values, okay? Unique value, and this J will keep iterating the whole array, right? So now what will happen, if they are equal, then what we'll do, we'll increase J, okay? Now, so our J probably will come here, which means this value were equal, right? So now we have here. So now the another situation is when nums I is not equals to nums J. In this case, right? This can be scenario, right? When this is not equal, then what you need to do? You just need to increase this left pointer, or say I pointer. You can give a name left or right, anything. Okay. So this, I guess I probably right or left name sounds good. Or IJ fine. I guess IJ are fine, right? So now you need to increase this I pointer. Why? Because on the place the I pointer already is, that is already a array of the unique element, right? So now when you increase this I, this will come here, right here, right? So now at this place you need to replace this value. You need to add this value. The value of j will come at the place of I. The value of j will come at the place of I, which means that now you will have this array updated as 0 comma 1 comma again the value of j. You need to replace the value of I by the value of j, right? Replace the value of I by the value of j, value of j. Yes or no? Tell me yes or no. That's what you have to do. That's what you have to do, right? So what you will do, you'll just replace the value. Means the value of I will be updated now. You will have 0 comma at the place of I. You will have 1, which was here, and then you will increase the j pointer as well. Okay, you will increase first what you did when this is not equal to, you increase the I pointer. Increase I pointer because previously I was pointing to the length of the sorted part, right? Now I should point out to the upcoming value. So now increase I, and then when you done this, then increase j. Then increase j. So now j will come here, j will come here. Again you will see value at I index and j index. You see they are the similar values, right? They are the similar values because now on this index you have what? You have at this I you have what? You have 1, and again on the upcoming j, j is here, right? J is here at this 1. So j is here. Again they are similar. So if they are similar, you need to increase j. So j will come here. Again you will check on the I and the value of j, because this has been updated to 1. So you'll see like they are equal. Yes, they are equal, which means increase j. Again, you will check with this one. Are they equal? Yes, they are equal because this has become 1, right? So now what you'll do? Again, you'll update j. So now see, this is different and this is different. When they're different, what you need to do? You just need to replace the value of I by the value of j. So which means that now updated array you will have by increasing I by 1, right? Which means that you will increase I by 1. So 0 comma 1. Now I has been updated, so I will point out to this index, right? At this place I will come here. So now you'll replace that value, and value was 3 there, you replace this 3. And after that what you have, till I you have replaced 3. And now look at this, at the second index you have replaced the I, the value with the I. Now remaining value is 1 comma 1, 1 comma 1. Now this is 3, and you'll update the j. J will point out now to 4. Now to 4. Again you'll see the value at I, the value at I which was this, the value at I, are these both the values are same? Like look at this, the current j is holding 4, the current j is holding 4, right? And the current I is holding 3. They are different. Yes, they are different. Then increase I, increase I. When you will increase I will come here, I will come here, and you will replace this value by the value of j, and the value of j was 4. So which means this 1 will be updated by 4. Yes or no? Then again what you will do, you will increase the j. Again you will compare the value of I with the value of j, which are similar, which means you will increase the j, and now j has gone the out of the length. The whole array has been iterated. So which means that you need to stop now. So now tell me your I is here, your I is here, and the value of I will be what? Tell me the index. 0, 1, 2, 3. The index will be 3. Tell me how many unique element you will have. How many unique element you will have? Count it. 1, 2, 3, 4, which means I plus 1. Right. So unique element will be I plus 1. Yes or no? So please repeat from replace value. Okay, friends, don't worry, we'll see another example. Okay. So now here what will happen? What will happen? The unique value, the number of unique value will have what? I plus 1. Right. So now I'll take another example to understand you more. Like I'll take another example here. Okay. I'll take, let's say we have nums where we have 1 comma 2 comma 2 comma uh, 3. Okay. And now what I want to just remove the duplicate values, right? So what we have to do, again we'll have a one initial pointer I here, and again the another pointer j here. We have two pointers side. We'll compare the value of adjacent elements first. If they are different, which means this is already sorted. If they are different, right? So which means that they are already unique. So then what you have to do, you just have to increase your I. Right? Increase I and replace value of I with j. in this case they are same, right? Anyhow, in this case they are same. So which means I, when you will increase, I will come at the point of j. I will come at the point of j, and you will replace the value of j with I, which means this will remain same. For this time, this will remain same because you have replaced 2 with 2, which is same. Nothing has changed, right? But what will happen now? I is pointing to this and j is pointing to this. After this has happened, you need to increase this j. You need to increase this j, and j will come here. J will come here, right? Now what will happen? You'll compare the value of I and j again. They are similar. If they are similar, then again increase the j, because you don't have to replace anything. They are already available, right? So now j will come here. When j came here at 3, you will compare the value of I and j. They are different. If they are different, then increase I. If they are different, then what you need to do? Increase I and replace the value of I with the value of j, right? With the value of replace increase I and replace the value of I with value of j, right? Value of j, which means that the increase the I means I will point out here, and the value of j is this. So replace this, which means that this will become 1 comma 2 comma, and the value of I will be replaced by 3 by the value of j, right? This becomes 3, and the last value will remain 3. And this value is we are not important for us, because this j, when you increase after swapping, after replacing the value, not swapping, after replacing the value, this j will increase. This went out of the array, right? Out of the array. So now tell me, if somebody asks you the number of unique element, if somebody asks you the number of unique element, what you will tell? What you will tell? Your I is here right now. Yes or no? Tell me the index of I, the value of I. The index means like this is 0, this is 1, this is 2. You will tell like how many elements you have till I. You will say always I plus 1, because the index, because I is the index anyhow. So this is 2. 2 plus 1 becomes 3. So 3 unique elements you have. Look at this. These 3 unique elements you have, and this is not a matter of concern. Okay, they already mentioned like once you have removed all the duplicates from starting, and you have reached the end of the array, then this is not the part of your concern. Those values will remain in the relative order, in the previous order, whatever they were. I hope it's clear now. The analogy, the concept is clear now. We can go for the code, right? I believe the concept, like how we can approach this problem, is clear now, and we can now approach to the solution part, to the code part, right? So I'll come here. First we'll write in Java, then we'll write in C++, then in Python or something. Okay. So now here, what I want is, I want the initial pointer I, which will point to the 0. The next value I want to start from 1 to compare something, right? So I'll start from j equals to 1, and again this j will be less than what? Nums dot length, and again j plus plus. Yes or no? So now this is what we have. Again here we want to compare, like again tell me what will happen. This loop will every time will keep running, which means the value of j will keep increasing every time. So we don't have to check the logic of the similarity. What we have to check? We have to check the logic of dissimilarity. So which means that if nums I is not equals to what? Nums j, right? If nums I is not equals to nums j, which means we have different value. And tell me what we were doing. If you have different value, increase I by 1, means I plus plus, then replace the value of I with the value of j, right? With the value of j. That's what we were doing. That's what we were doing, right? Value of j. Now, value of 2 to 3, sir. I'll explain in this example itself. Okay, we'll take this code again and we'll understand again. Okay, so don't worry. So now what will happen? Right now you have updated the value, and again here you will return I plus 1, because I will point out to the index, and anyhow indexes start from 0. So let's say if index is 2, which means you have 3 elements: 0 index, 1 index, and 2 index. That's why we're returning I plus 1. Okay, cool, yeah, cool. So now I'll tell you what's happening here. Okay, I'll tell you what's happening here. I'll take this example. Cool, I'll take this example. So now tell me what will happen here. In step number 1, what will happen? You have what? I, which is j, which is 1. So tell me the condition 1 is less than the length of the nums, right? And length of the nums is 2. So 1 is less than 2. What you need to do? Tell me what you need to do. you just need to check like if they are different, like if they're different, then you need to do one thing. What if they are different, like the value at the 0th index, okay, and the value at the ones place. First we'll do one thing, we'll run this to understand like it's running fine or not, then we'll go ahead. It's working fine, I guess. Okay, so now we can go ahead. Now here let's see what will happen. Nums0, which is this, right? Now tell me, nums0 is what here? Nums0 is 1 here, yes or no? Nums0 is 1, and again the value of j is 1. So nums j is what? Tell me, the nums j is what? Nums j is at the bun index. You have what? You have bun. So they are not different, right? They are not different. So which means that what will happen? You will increase the value of j. You will increase the value of j, right? Then what will happen? You come here, you will increase the value of j. Okay, cool here. So now the index j will become 2, right? And here we'll check like 2 is less than 2, and we'll return no. Something is missing here. It's not appropriate. Starting from bun, and at bun index we have bun, and this is at 0 index, right? They are not same, which means that this will not work. We'll increase the value of j, which becomes 2, and anyhow 2 is not less than 2, right? 2 is not less than 2, and the I was pointing out to what? I was pointing out to 0 as of now. And again, when we will increase this, then the value of j becomes 2, and this will not work. How is this working for this solution? The functions will return k equals to 2 with the first two elements of the nums being 1 or 2 respectively. Yeah, probably the solution should work fine. But anyhow, because of this condition, okay, how many length we have actually? Length we have 3, not 2. Length we have 3. Oh, that's my bad. Length we have 3. Okay, I was thinking like how it will work. So the length was 3. Now here, so sir, be our index or value, sir? So these are the indexes actually. Okay, these are the indexes, not the values directly. So now here we have this length was 3. Now what will happen? The value of j will be increased by 1 because we have reached the end of the loop. This will not work. So which means here automatically the value of j will become what? J will become 2. We'll come here, we'll check the condition again. It's 2 less than 3. Yes, it is. If this is less than 3, which means this for loop will work. And if this work, you'll match the condition again. You have I at 0 index, which means pointing out to 1 still, and you have nums j, and nums j is now pointing out to 2, which means that you're pointing second index, which is what? Which is 2. Look at this. At second index we have 2, which means we have different values. So this condition will become true at 0 index, and at the second index we are not having same value, which means that you need to replace this value by 2. Which means that you need to increase, because I is pointing out to here, but I should point out to here now to get the upcoming value. So that's why we have increased the I. Now the value of I will become here what? The value of I will become 1, because we have one different value. So now at 1 index it will replace the value of j. So which means that at nums 1 index you will have the value of nums second index. Okay, num second index, which means that you will have this array. Which array? This one, like 1 at the 1 index. Now the value of second index has came, which means 2, and again we have 2. Okay, so what will happen here? Here the value of j will be increased. Now j is 3, and this condition will be false. 3 is not less than 3, right? So this condition becomes false. When this becomes false, we will not execute this anymore, which means that now you have at starting you have unique values, and all the remaining values are at the end of the array, right? And that doesn't matter. That's not part of our concern, right? So now what we need to return? We need to return number of unique elements. Now tell me, if I is pointing out to this value, this value right here, which means the value of I is 1 here. And tell me the number of unique elements. You have 2, which means whatever the index is, because index is starting from 0, and right 0 and 1 index. So which means that you will have the element till what? I plus 1, because I is pointing out to 1 index here, and till 1 index you have 2 elements, and till, let's say if I ask you till 5 index, you will have 6 elements, because indexes are from 0. So now the number of unique element, how many you have? You have what? You have I plus 1. You have I plus 1, which is this, right? So now you will have what? You will have this I was 1, and 1 plus 1 becomes 2. I was 1, 1 plus 1 becomes what? 1 plus 1 becomes 2. Yes or no? Tell me. I hope it's clear now to everybody what we are doing. The same thing again. We will have 2 pointers. The left pointer will increase one only when you have the right pointer's value different. And if they are different, you will update the value of the left pointer by the value of right pointer. That's what we are doing here. Tell me, is this clear? Tell me, please. Correct, Prince. Correct. Tell me, is this clear to all? Please do let me know. I hope it's clear. Now we can write the code in other language. Other people can also learn here. I will not write the whole code, because anyhow this syntax is completely same in C++. Okay, you don't have to do anything new. The same syntax is following in the C++ also. The same syntax. Like the variable declaration is completely same, loop syntax is completely same, if condition is similarly same, operators are completely same. So which means that now if I run in the C++, it will work fine for me. Okay, if I submit this, it will work fine. Oh, now what happened? Length. Okay, actually vector does not have length. I guess it has size, or what we can utilize here is, I guess here in vector we have size method, if I remember my C++. Otherwise we'll use a for each loop. That is also fine. Now, okay, so that is only the difference, because in C++ for dynamic array we use vector, and that here we use the size method at the place of length. Okay. Okay, Sanatan. Now what we'll do, we'll submit this code. Okay, already submitted. Cool. Yeah. So now we'll do in Python also. In Python, again, there is nothing different. You'll write in the same way. Python is actually it's a more easy than the previous one like Java and C++. Why? Because you don't have to declare the data type also. You're writing like we have declared one pointer I, and also not the semicolons part, right? And you'll use a for loop. We were using there, like we were using a geo pointer in range. So that's a syntax for the for loop there, right? And you're starting from one index, the starting index, and the ending. The ending was the length, means the length of what? Length of the nums list, right? And after that, what you were doing, you were writing a condition that if what? If nums I is not equals to nums j, right? So in this case, what we were doing, we were increasing I1. Now in Python, there is no increment operator, so you have to do this thing. I plus 1 is equals to 1, which means I is equals to I plus 1, incrementing the value of I by 1. And now here you can replace the value nums I, which is equals to nums j. Okay, nums j. Now you're updating the value here, and at the end, here the indentation matters. Okay, indentation matters. After this, you see this, we have 4 character indentation, which means this if comes under for. And now we want to return, which means we have to go out of the for loop. So now look at this. If we are in the parallel line, which means that we are out of this block. So now here we can return. I plus 1. Okay. So now this is for Python. I hope logic is clear. And now this code is also sensible. There's nothing. Oh, no. What's saying? Invalid syntax. Invalid syntax for what? I is not equals to j. Oh. Actually, the habit of writing code in C++ and again I have added a semicolon here. You people wanted to do this, and anyhow I've learned Python along is before 3 years, but now I remember here you cannot add that curly braces. You need to follow only indentation. Cool. Yeah. So now here this is in Python also. I hope it works fine for everybody. Okay, we're beating 100%, 0 millisecond. Can somebody tell me the time complexity of this? Can somebody tell me the time and space complexity for this? And how do we add comments in Python? You can have triple time that particular thing, like double quotes, right? Okay, so basically we are arranging the unique elements and returning till that index. Correct. In this, the duplicate elements are pushed to the end, but we are returning till the unique element index. Correct. Not actually to the end, we're just ignoring them. Okay. Correct. Correct, Lieutenant. Correct. The time complexity, the TC, will be what? Big of n. Why is this? Why is this? Because we have to iterate the whole array. We have to iterate the whole array. Okay. And tell me what will be the space complexity. The space complexity. SC. Tell me. Space complexity will be big of 1 because we are not utilizing any other data structure. We are doing in place. Right? We are doing what? We are doing in place. Look at this. So space complexity is constant. I hope it's clear to all. Correct? I hope it's clear to all. See you in the next live. And now from today onward, we'll covering the codes in the all three languages. But at least I want something like the people of the Python, C++ here. You have to mark your attendance like C++ was good, sir, or something like I can get an acknowledgement like you are all you really wanted in Python or C++. Okay. Cool, Siddharth, cool. Okay, bye-bye to all. And again, before leaving, if you haven't subscribed, then subscribe it. If you haven't liked it, if you really feel like this video was helpful, then like it. Or again, press the bell icon by which you can get the update of the next upcoming video. Till then, bye-bye. See you in the next live. Bye-bye to all.